Hello, hello. How's everyone doing? Pretty decent amount of people today. That's good. That's good. All right, let's see here. Hello. You do not have to turn on your cameras, but if you do, that'd be pretty nice, right? Okay. So everyone here for Python, correct? Nice. All right. So how I'm gonna structure this is gonna be around 40 minutes, maybe 35 minutes of material that I plan on covering, and then like 10-15 minutes of if you have any questions about how AI learning works regarding any of the classes, you can let me know as well. So that'll be the last 10-15 minutes. So I've been teaching here at AI Learning for about over a year so far, and I think it's been a really enjoyable experience. So I hope you guys enjoy as well. If you're new teachers or just here for some extra training out of your own accord, I hope everyone learned something of value today, right? Okay, so Python training today, June 25th, 2022, 003 Python. So the Python curriculum actually encompasses more than just one level. There is a second level, and then it goes on. And each level introduces more advanced topics as you progress through. And then there is extra classes at the end, like Python AI, which are a little bit more difficult to understand and to conceptualize. But the Python curriculum is very expansive, and it's always adapting, it's always expanding, it's always getting better. So if you also have any feedback about it, it's great to let us know. So for your Python classes, what you really want to have is Python 3. First though. So whenever you teach your classes, you want to have Python 3 or higher, and you want to encourage your students to have that as well. Some libraries you might want to introduce might require Python 3. Some syntax issues could occur if some students are using Python 2 and you're using Python 3. Although those are kind of rare. If you're teaching in class, make sure to recognize the difference between Mac and Windows. Installation in both of them are not the same. Running Pythons like idle, which is the main environment that you should use at the introductory level, is slightly different between Mac and Windows. Again, about where you start the files, where you save files, all that. And differences are pretty slim if you have a positive environment, and you do that by building relationships. So you want your students to not only understand the material, but you want them to also enjoy what they're teaching, right? And do what they're learning, and you want to enjoy what you're teaching. So you do that by building a positive environment. You encourage students to lead. So during classes, you want them to answer questions and not you just lecturing them the whole time. It's not supposed to be entirely like a college lecture. It's supposed to be more like a classroom environment. You also want to maintain balance, meaning that you have the students understand the concept. So you have some students who are really smart. They know everything. They probably have previous experience. They do a lot outside of the classroom. And then there's some students who need a little bit more help. So you want to maintain that balance where you're giving support to the students who need help, but you're also giving challenging and meaningful coursework to the students who don't, right? Who are trying to advance as much as they can. Can you guys all hear me okay? I'm not sure if my internet is doing well right now. Okay, can you hear me okay? No problems?
Yeah, no problem.
All right, thank you. So why Python? So Python is what we encourage after the Scratch level, and the reason is because Python has a very broad reach. It's known as like the Swiss Army knife of programming languages because it's very user friendly. The syntax, the functions, everything is made to be user friendly, right? So like initializing variables, initializing functions, syntax is simple. Like when you do print statements, you all know you just write print. Other programming languages like C++ require you write like console out, and then Java requires system.out.println line. So those are kind of a little bit more difficult to grasp compared to just the Python introductionary, which is print, and it's really easy. But Python is known as a Swiss Army knife of programming languages because it's utilized for various different things. It's used for AI, it's used for data science, used for web development. So it has a lot of libraries. So it's not just for user friendly, it's not just for beginners, it's for everyone. So it's very versatile. We really want to push that when we talk to the student, that you're not just learning Python at this level, but you can use it for future use. All right, so this is the main start. So now we're actually talking about concepts here. So print statements in Python allow the use of the console. This is the first thing you should introduce, which is print statements, so they can see how it works, right? And you can print any data type. You can use math, such as addition, multiplication, division, subtraction, etc. There's other math you can use, not only in your print statement, but beyond, such as integer division. If you remember, it looks like this. You got your remainder, which is called the modulo, which is a percent sign. So these are also other forms. And you also have your exponents, which is initialized with 2 asterisks, right? So it's just more math functions. You can use operations, but print statements are very, very important. You show the students how it works. Right. So anytime you guys have any questions, let me know. And if I'm going a little bit too fast, let me know as well. So data types in Python, they basically encompass 3 main types, which are strings, integers, and floats. So while in Python you don't declare your variables, you don't write like string x is equal to hello. Behind the hood, Python actually initializes as hello as a string. If you don't know, Python is actually written in C. So C actually does this under the hood that you don't see, but you still want the students to understand that there's different data types, such as strings, integers, and floats. You know this when you're trying to convert between types, and that some types are only used in certain situations. You can't do math with a string, okay? You can't like do like if you do 5, right? So if your x is equal to 5 like this, and you do x times 3, what you end up with is 5, 5, 5 like this. So it's going to be just the word 5 3 times, right? It's not going to be actually what it should be, which is 15. So that's pretty easy to understand, I'd assume. And converting between types is something else we want to understand. And you take strings, right? So basically anything can be converted to a string. You can take a number, convert it to string, a float can convert to string, integers, right? And you just use it with this casting method, which is str. You can convert to an integer, but you have to recognize that sometimes it won't work. Like you can't take like hello. If you try to integer cast it like this, you're gonna get an error. It's gonna say it's improper. It doesn't work. So you have to be careful and make sure the students recognize you have to be careful. Like you can convert a string of 5 into an integer. That's no problem, right? It's gonna just convert it to 5. But if you try it for things that don't work, like hello, it's gonna run into an issue. So what you could do is use a try catch statement, but that depends on if you're trying to explain that to your class, if they're comfortable with that. And then a float statement, a float comparison or conversion. Again, same process. Like I can use, if I have 5.5 like this, I can convert it to a float. I can also, when I ask the user for input, I can tell them to specify as a float, and they put a decimal, and then it'll just take it as a float. So just recognize this. And yeah, so input involves the program user. So the user will input whatever they want, and it's taken as a string. So let me make sure you guys recognize that. Let me pull up idle. I usually use PyCharm, but for simplicity purposes, I'm just going to run idle. So again, if I take x is equal to input, then I say whatever I want, right? So I'll just say, please input anything, right? Nice, capital L, nice. If I take like 5, right? My 5 here is actually a string 5. So if I use this, you can see it's 555 like this, right? So what I have to do is when I take input, again, input, I'll say, please input a number, and then it'll cast it directly as an integer. So it's utilizable. So you have to recognize, again, the input by default takes in as a string. So that's why you have to cast it like this. So many times you're going to need to use this for like math. So just make sure you understand this. Variables are similar to like algebra. So when I talk about variables, I always ask initially, do you guys know what algebra is, right? So if they know algebra, they know like x is equal to like 5, y is equal to 3. So if you understand algebra, it's the same process, except you not only store numbers, you can also store, words. So I can do like word is equal to hello. I can do color is equal to blue. They're stored. You can use them in the future. It's good. So any questions up to this point? Any questions? Everyone's good? Cool. All right, so another thing we really want to help students understand is formatting. So when we format a string, we don't want to just, throw it in there and use like plus or equals, right? You guys are probably familiar with that, which is adding strings together. Because by default, strings are not mutable, so you can't change a string directly. So you do plus or equals. So you make a new string equals the original string plus something else. So if you're printing something, you can just keep doing that. Or if you're using you're trying to make a new string, right? You can just keep adding strings. But if you want to format it in a way that makes sense, use something called an F string. So you just initialize it with an F at the start, format string, and then you just put in whatever you want. So it looks something like this. My name is, and then you can put in your variable directly like this. It doesn't matter if it's integer, string, float, whatever. It works without an issue. And then you just close it like a normal string. All right, so that's when I do it. It makes your code more readable. So that's the importance of formatting, right? So your code's readable, you understand it more if you come back to it. And then the students also be able to make their code easier for them to see. And there's other methods you can use, which is the % one, right? So you just do like this %, and then you store the variables at the end. So that's another formatting method, which looks something like this. So you just write whatever you want. So hello, and then it's like %s, then I end here with a %, and then I put like my variable here. Let's say it's like color. Then initialize color previously as like blue. So it knows what color is, because it sees the %s, it goes to the first thing inside of my container, which stores the variables associated with a string. So the first thing is a string, right? So I have to make sure it's in order. If I had like %d, that's an integer, and I put like this, it would cause an issue because it's going to the first thing inside this container, and it's a string when it should be actually an integer. Right, so that's another concept you have to familiarize yourself with. And when students ask, again, you have to make sure they understand that it makes your code more readable. So there's 3 types of containers we really focus on. And the first is lists. So lists, they start by indexing. They start at 0, 1, 2, and they keep on going to the length of the list minus 1, right? So if the list is length of, let's say my list, it looks like this. And again, you can store anything inside list. It's not like other programming languages where you have to specify, like, it's a character list, string list, integer list, whatever. So like this, the length of this is going to return 4, but to index, my indexing goes 0, 1, again, etc. until length of list minus 1. So length of list minus 1, that should be 3. So 0, 1, 2, 3. Cool. Dictionary is another one. If you're familiar with hash maps, dictionaries are basically hash maps in Python. You store a key value pair. So like, let's say I have a dictionary associated like this. So I have like color, and then I can just blue or something, right? I can just, or I can do my name, and then I could do like anything I want associated with it. I could do my time zone right now, which is Pacific Standard Time. I could store like anything. Then I can like put other people like randomly. Something like this. They just store a key. So this is your key, and then the value associated with it. So when you call it, it returns this, the value associated with it. It's kind of like a list, and instead of like indexing it, so you say like list of 1, you put in the key that you're storing. So, or you're trying to retrieve, and it gives you the value. So it's like a more efficient list. Another thing you have to recognize, if students ask, is that it's actually more efficient in terms of runtime to go through this rather than to go through a list, because a list, like, you have to go through every value to find the value you're trying to sort, whereas this, you can just access it more easily. And in Python, lists are mutable, so I can do like append. So append, like, let's say my list is equal to mango, peach, orange, right? I can append to it pretty easily. So list.append, and I can add like grapes, and then my list will mutate to accommodate for that. So I don't want, how do I write it like this? Okay, so I'll write like list is gonna return basically. So it's gonna look like this: mango, peach, orange, and grapes. All right, so something like this. Append is a function you have to know. Another one is remove. So I can remove a value. So like orange, mango, peach, I can insert. So I insert, like, I choose the index, then I also associate the value associated with it. I can do list.pop, so I remove the last value. A lot of things you can do with lists. Other things you can do are in. So you can check a value inside a list. That's something you can do. So dictionaries have similar things, but you just initialize like this. Let's say my dictionary looks like, again, what I had, Ollie. And again, it's not, you don't have to initialize a type. I can just say whatever I want. So Ollie, Pacific Standard Time. James, Eastern Standard Time. If I want to add a value, I could do something like, and recognize the difference in initialization. So lists use square brackets, dictionaries use curly brackets, and tuples, which we'll go over in a little bit, are use parentheses. So I could do like dict of Alex, and I can store now, let's say Central Standard Time. So then my dictionary will be appended, and it's going to store Alex, and then, so again, it's going to have Alex and then Central Standard Time inside of it. All right, so hash tables are, again, used as dictionaries. Hash maps are used as dictionaries in Python. So if you're familiar with other languages like unordered map, and C++, they use dictionaries in Python. Java, I think it's called, is it called hash map or just map? Again, it's like that, but in those languages, you have to specify the type, which are like strings and floats, whatever. Python does it for you. The last thing is tuples. So tuples are basically lists, except you can't mutate them. So I can't do .append, I can't do .remove, I can't do .insert. It's constant in the memory, it doesn't change. And so they're very restrictive. So they're like arrays and other programming languages. Again, if you have experience with those. Any questions? If you have a question anytime, just let me know. Everyone good? Everyone's good? All right, seems like, yeah,
yes,
thumbs
good.
up.
Thank you.
Thank you. All right. So there's two different types of loops that we really focus on, the for loops and while loops. So for loops are more of an iterative approach. So in Python, whenever you use for loops, you can use them in two ways. I'll go over those in a second. And then I use while loops for conditional approaches. So like while this thing is true, like while running equals true, right? Continue to execute whatever you have. Okay, so you continue to execute. For loops, on the other hand, are used to iterate through values. So if I have like a list, like let's say it's 5, 7, 8, 3, 9, right? To iterate through this, I can do for I in list. So it just gets every value inside of the list. It's like a generator. And then it'll print, it'll get 5. So the first run, and let's say I just print it. First run, I is going to equal to 5. Second run, I is going to equal to 7, and so on and so forth, right? So that's why I use for loops, because they're very easy in this sense. But you can also use for loops in a more classical way, which is like for I in range the length of the list. So if I just pulled up the list theoretically again, so list is equal to 5, 7, 8, something like this, right? This time it's I is no longer going to equal to every value inside the list. It's going to equal to an index. So what's going to equal to a number. And the range function is what you'd use here. And the range function has these arguments. You have, by default, you only really need the end one. So start by default is 0, which is the start of the, whatever you want, right? Starting of like the iteration, and then it's inclusive. End is equal to, you have to initialize it, but it's exclusive. So, so if I do like, it's gonna go 0, 1, 2, 3, 4, 5, ignore 6. And then I have like a step if I want, which like says how many jumps I do. So if by default it's 1. If I put like 2, it's gonna jump every other number, right? So that's just how I'd use a range in a for loop. And then I could do like print list at I. So it makes it a bit more difficult. Whereas you could just do for I in list, and it gets every character at that place. Right? This does the same thing, but it does it for you by default if you just use for I in list. If you want to use a while loop to iterate through this, which I'll just again make 4, 5, 8, 7, 9, 3. I have to initialize the variable beforehand, like I0. And I can do while I is less than length of list. Print I. So it does the same thing, but now you have to initialize the variable here, and it's a little more confusing. Again, I use while loops. So continue running while this is true. It's not a set amount of times. If you have a set amount of times you want to iterate through something, I'd use a for loop. Do you have a question?
And of course, don't forget to do I++, like I
Yeah.
I
Yeah,
one
right
by one. Otherwise we will be, hey, can we do I++? Yeah, like that.
Yeah.
We can do this in
like
JavaScript.
Yeah, so like this, yeah, that's a good point. You do have to increase I or it'll be stuck here. So yeah, I use a good point though. Thank you. One of the things you have to recognize in loops, you can use break statements, you can use continue statements. So that means you end the current iteration. Break statements means you leave the loop entirely. Continue means you go the next iteration. But yeah, so while loops, again, if you don't have a set amount of times you want to iterate, you'd use a while loop, in my opinion. But you could use both theoretically. All right, cool. So functions, another part of Python, and they're used, you initialize them using def. So I don't have to initialize a type, like I don't have to write like void or int or whatever. I just write definition. And I can just put the name. So I make a name that makes sense, like multiply values or something. Or product makes more sense, but whatever. I put a colon at the end to initialize that it's completed. And then inside of here is where I put my arguments. So like X and Y. And then I can decide to have a return statement or not. So like this situation, you do like X multiplied by Y, that's my return statement. So the return statement is like the result that's comes about this function. I don't have to specify the return type again. Like other programming languages, I include the arguments inside these parentheses. They're copied over. The exception is like lists. Lists are mutable and they're stored separately. So like if I do, let me actually pull up an example here. Let me use Python to explain this difference function. All right, cool. Make a new project. All right. So let's say like list is equal, or let's say take like X is equal to 5, and then I have a function, like a function called modify value or whatever. Then I take an argument here and I change like X is equal to 9, right? And then I call modify value of X, then I can print X here. And you can see X is still 5. Now, if I had like list is equal to 1, 2, 3, 4, 5, then I call modify value of list, and I do like list dot append 6, then I print list. 6 is now here. So the difference is lists are stored differently than variables, like integers and strings. So let me write that again. So definition, integer test, X, then I change X is equal to like 6 or whatever. Then I like this, right? And then I do like definition, list test, and I just take in a list. Then I change list dot append like 9. And I just like say set X equals 5 here, and list by default is 1, 2, 3, 4, 5. And then I call integer test of X. Then I do list test of list, right? And if I print X here, then I print list here. You'll see that list was modified. The 9 was added to it. The integer test, when I ran integer test, it changed X here, but it didn't change it when I printed it out here. Again, so let me pull up my annotation tool here. So lists are immutable, stored in memory. So whenever it's, if you draw it like a memory diagram, which is a little bit more, we're going a little bit more than we need to. You draw a memory diagram of where lists are stored. Right, they're stored separately than the integers. It like points to something else in the memory. So every value is pointed at somewhere else. It's not like actually stored like integers. if you think about it, like a list doesn't actually hold values, it holds like a memory address, and it has values associated with it. If you're used to C++ and other programming language like that, you'll recognize, yeah, you need to use a pointer, you need to use addresses, stuff like that, to in these situations to change X. So if I want to change X instead, I would return X. Then I could do like integer test. I change X now equal to integer test. And now, let's see. Oh, now if I run this, right, X now equals 6. So I have to return X, so then it stores here. Because when I call integer test of X, it's storing a copy, not the actual address location, like it's a list. All right, so some stuff there. So any questions about that? Okay, cool. So Booleans are another thing that are another data type, but they're not really like really store them as a Boolean, but like you can make something like running is equal to true or something like this, but you don't really use them that much. You don't really start by describe. We start explaining Booleans a bit later on in lessons. In Python and other languages as well, just true or false. All right, so your Boolean values are true or false. You can use a Boolean function to like get a value, and Boolean will return false only in the situation in which you give it like a 0 number. Like Boolean of 0 would be a false. Boolean of 0.0 would be false. Boolean of like an empty string would be false. Boolean of an empty list would be false. Boolean of an empty tuple, false. Or let me just, Boolean of a empty dictionary is also false. The reason is Boolean values are associated in like machine language. So if you know machine language, you have zeros and ones. Zeros are false, ones is true. So whenever you see 0, it's actually false. So that's how the Boolean function works. So again, an integer of 0 is basically like nothing. You have nothing there. Same thing with Boolean of a float, string, dictionary, tuple, dictionary, etc. Right? Now, if I do like Boolean of 5, it's gonna return true even though it's not ones and zeros. It's because only zeros are associated with false. So that's why you'd use them. But this Boolean function is not used that much. You might not even have encountered it. You might have just like initialized it yourself in the past. So Python logical operators. Ones are and, or, and not. Value comparisons are like this one, that's greater than or equal to, less than or equal to, not equal to. Memory comparisons are slightly different. Is and is not. So again, we say this right away in our curriculum, which is that this is a value comparison, this is a memory comparison. But it's not applicable till you look at lists. So I can give an example with a list right here. So let's say I make a list equal to like 1, 2, 3, 4, and then I make a copy of the list and I make it equal to list, and then I make a shallow copy of it. And if I do print list is equal to copy list, then I print list is equal is copy list. You'll see true and false. So these values associated with copy list are the same as list. I made a shallow copy of it, meaning that all the values associated with this are stored here, right? So all the values inside of list are now stored in copy list using a copy. Now it's saying list is equal to copy list because the values are the same. Value comparison. List is copy list, it's a memory comparison, and copy list again and list are not the same thing. So these are stored in different points in the memory. Again, like I said, lists are stored in memory, so it's a little bit different. Now, if I did like copy list is equal to list, right? It can be true because this is not a copy. I'm just saying my address that I'm pointing copy list at is the same as the address of list. So if I modify like copy list of like 2 and I set it equal to like 6, right? And I print list and I print copy list, you'll see both are modified because I'm just saying this is like pointer, this address of copy list, this copy list of basically an address. It's just equal to list. All right, so that's the difference between memory comparisons and value comparisons. You tell the students right away in our in the curriculum, but I try not to go into it. So I basically ignore it. But in future reference, you do have to explain to them they have to use is when using lists, and then value comparisons using things that are not mutable. Shallow copying a list again gives true, it gives false. So just that. So any questions? Okay, cool. So the last topic I really want to cover is object-oriented programming. So Python, even though it's not known as an object-oriented programming program, you can still use like classes, you can still use like class function and attributes within your code. And we use this, and we initialize values inside the, like let's say I make a class like new class, right? I start off with an init statement, and I could do like self.x equal to, like let's say I pass the argument x, right? And I make self.x equal to x, so I'm making blueprints of the class. So this is like the higher level. Then I can have class functions associated with this, like define, print val or something. I can just print self.x. So everything is stored whenever I make a new copy or new object of new class, like value equals new class. I should probably initialize x as 5 or something, right? I have self attributes stored, and then I have these functions I can now use. So let's say I do val dot print val 5, because that's the value associated with it. So these are functions only callable through this new class object. So anyone who is an object of new class, I can use this function. And again, I can store various attributes like name. So self.name is equal to like name. Define print name self. I can do print self.name. So val.print name. Oh, I forgot to initialize here. Poly. Right. So print name here, it's a function. I can change these attributes in the future, such as val.name is equal to, I just say, let me just reverse my name. Let's say I print it again. You see it's changed. So again, a class is like a blueprint. And then every time I make something, it's a copy of it. So val is like a copy of new class with these functions, class functions, and I have these attributes stored into it. So in this example, x would be equal to 5, which I chose, and the name is equal to this, right? But then I changed it here. Cool. So classes, you can do a lot with them. Again, like the way you should explain it is like a video game. Like if you have a video game, the character has, like lives, their like association, their skills, and other things attributed with them. And there's functions like maybe attack, maybe defend, maybe block, all sorts of different things, right? So again, these are attributes, and then these are functions inside of it. Then I can have like class attributes that I initialize up here, which are universal to all class objects. Cool. And in it is there a constructor. Like if you know from other programming languages, you have a constructor. Like in C++, I know you can just write it out. Like when you write out like when you write a class, you need to have a constructor, and then you just set the attributes in similar manner. You don't write init, it's just something different. This is a dunder method. So that's another thing you should probably recognize, dunder methods, which means double underscore. So common dunder methods for classes are like length, like add, like repr, which is the print function. These are all initialized inside of your general classes. Like a integer is actually a class, a string is actually a class, a float is actually a class, and they have these methods initialized beforehand. Define repr, which again is a print method. Greater than, something else I can use. So whenever I use this symbol, when I call the greater than symbol, it's going to go to that function. So cool. All right, so that's it with content. So I would assume there's some questions. So does anyone have any questions? Everyone entirely comfortable with the material?
Yeah, I feel more comfortable with this than the Scratch actually, because I haven't seen it.
All right, that's cool. Yeah, I don't like Scratch. I don't really like teaching it. It's like, it's not very, it's just not natural when you program for so long and then you look at Scratch, it just seems so like abnormal to try teaching it like that, right? So yeah, I much prefer teaching like coding languages like Python, C++, Java. So those are three I focus on. I guess so you can use like JavaScript. What was other ones? Julia is another programming language. Is HTML a programming language? It's like a script more like. But yeah, that's good to hear. Anyone else? Any questions or comments? Anyone want to add another material, like another topic to cover?
I actually do. Like I get criticized for using for loops when you should use like, I don't know, lambdas. I don't know why they like it more.
You prefer using for loops than lambdas?
No, like and then like if I have like a coding interview, they don't want to see me use for loops. They usually use they want lambdas. I think it's more efficient or something. Or for like coding quizzes too.
Yeah, I think at our level that we teach, we don't really cover lambdas. We just focus on like for and while loops. Those are the loops we focus on. I mean, if the students want, let me recognize the syntax for lambdas in Python. Lambda Python. I hope it's not too. Yeah, it doesn't seem too. I mean, you know, you can talk about other things like list. What is it? No, not concatenation. It's like list
comprehension.
Yeah, list comprehension. Like you could use that again. Like that's another thing that's more, I guess more proficient and more efficient to use, right? Than just making a general list. But again, I feel like the material is not so specific. You have to use like list comprehension versus like normal list creation, or like lambdas versus like normal for loops, or something like that. But yeah, that's a good point. If you want to teach lambdas and the students are up to it, you can probably mention it, and some students will probably be like, "Oh, I want to see that in the future," and try it themselves, right? Cool. Any other questions?
Hello. So if
Yeah.
if a TA wants to be an independent teacher, where can he? Like my son is currently a TA. He wants to know if he could get the teaching material so he could prepare, so then he could become a teacher in the future.
Sorry, can you repeat your question?
Question is that for like my son is the teaching assistant. He wonders if there is a teaching material that he have access to so he can prepare himself for being independent teacher.
Yeah, so the material is all on the ThinkLand website. So if you access that, there's material regarding, like the whole curriculum is on the ThinkLand classroom or the ThinkLand website. You can access it, look over, review it. And if you're doing well as a TA, right? I mean, you should hopefully be able to get a teaching position. It's because then you have, practice knowing the AI learning curriculum, how it works. So yeah, if he's doing well as a TA and he knows the material, I think they do evaluations if they're recorded now or they're still doing it in person, like a Zoom meeting. He can do evaluation, see if he should be a TA or teacher. Yeah, so he can do that. The material is all in the ThinkLine classroom. If you need help accessing it.
You said the material is if he has to log in, right? He has to
Yeah,
log in to see the material.
yeah, and then there should be a start here class in the ThinkLine like here. Let me see if I can show you.
If he cannot see it, he will contact the
Yeah.
whoever is in charge. Okay. And as a parent, can I see the material myself? Because I'm logged in. I don't know if he could log in, but I could see what, Oh, I see. This is.
Yeah, so you go to like the material. So you go to the ThinkLine. Yeah, so it should be right. These are classes. Start here. And then
I don't see that because start here is under where?
Well, it depends on your on how you set it up. But if you can't see start here, maybe reach out to Michael and ask him how you could add it. There should be all the materials here, like 003 Python. Then you just hit the join the classroom, and then it should link you there.
Link you to all the class material.
Yeah, links you to all the class material, and then you can just see it. Again, so it says like class 1 introduction, level 1 unit 2, like all this, right?
Yeah.
So if you sorry.
So then you will teach following these. I mean, you're gonna teach following the material. You cannot create your own material. You have to teach using the material, right?
All right. So there's some classes that I teach that like no one has taught before. So I just make the material beforehand. I just like think about it. But like for Python, like there's been a lot of people who have exhausted the course. Like a lot of people have went through all the course. So there is all the material here. It should be good enough. You can definitely add to it, but you have to focus on making sure you have all this material covered. Yeah.
I see. Yeah. So that is the, I cannot see it. So I have to make sure that my son, so as a TA, he has a account, right? He will have account.
Yeah. Liana, did you send that link in the chat?
Mina, please try to visit by this link.
I did.
That option, this settings sign, I didn't have that too. So I copied this link from last sessions and it opened for me. You can try this. Check if it works for you.
I see.
It works?
Yeah, I think I see something.
Yeah,
here.
that's good.
It says start here. I see the start here.
Yeah, that's good. Thank you.
It wasn't visible for me too, but I just copied the link from last sessions. Yeah.
Oh, thank you so much.
Yeah, thank you. It's been a nice. Because I remember when I logged in initially, it just was there. I'm not sure if they changed it recently. But yeah, thank you. So okay, any other questions? Any other questions? If no one else has any questions, you can leave if you want. Is everyone good?
Yes. Thank you.
Well, thank you for coming. Thank you, Liana, for your help. I hope I'm saying your name right. Yeah, like attaching the link. Thank you. Yeah, I hope to see you all as teachers in the future. You'll you'll come to love AI you're learning and think and hopefully as your time continues here. Thank you. Thank you, everyone.
Thank you.
Have a nice day. Bye-bye.
Bye. Have
You
a good
too. Bye.
weekend. Thank you, Ali.
Thank you. You too. Bye.